All right, the fourth and final part of the LeChateliers Lab is looking at a chemical compound which is called cobalt 2 chloride. Cobalt 2 chloride is inside of this sealed barrel pipette. I've sealed the end of it utilizing some heat and a clamp. And inside of this chemical compound, copper 2 chloride, as you can see in solution form, it kind of has this purplish color to it. Okay, instead of adding something to it, what the stress is now going to be a temperature stress. Unlike the other ones, which were either concentration changes to the vessels, we are now going to look at how temperature can affect equilibrium reaction. So this system is in equilibrium, and the reaction is going just as much forward as backward, and the result is this purple color. We're going to stress a system, and from adding additional heat or removing heat, it's going to draw the system either left or right of the chemical equation. Now, in the test tube on the beaker on the left, I have heated the chemical compound. Right now it's around 50 degrees, and I'm going to place that barrel pipette into it. I'm going to let it sit there for a few seconds. I have a second test tube that I will use as a reference so we can see what happens. All right, so I'm going to now pull this sealed barrel pipette. So in putting it in heat, you can quickly see now the color change that has occurred in it. So please make note of that into the data table. All right, that placing the sealed barrel pipette into the hot water causes the following chemical change. Okay, the reaction is either going to shift left or right. Look at the chemical equation given, and very quickly by the color change you should be able to indicate which direction it is shifting. That'll also tell you if this equilibrium reaction is either endothermic or exothermic. Now we're going to place that pipette now into an ice bath, which contains cold ice water. I'm going to let this sit here. And this might take up to a minute. But if you can clearly see, we are starting to see more and more of a temperature change. I should say temperature change, but a color change with the addition of the cold water. So now, because the sealed pipette is inside of the ice bath, thermal energy is being pulled from it, and we should now see it change to a different color. Hot turned it blue. And now we can see the new color is substantially pinker than what it was before. And that would make sense because in equilibrium we have both pink and the blue making this purple color. So now, again, work on your justification. I've created a LeChateliers explained worksheet that you can read through. And so with this temperature change, find where I talk about heat stresses and how LeChatelier helps explain why a reaction goes to reactants or products. Again, if it's endothermic, it gets shifted one way. If it's exothermic, it gets shifted the other way based on either being placed in hot water or cold water. Okay? And that concludes the LeChateliers Lab. Once you've got that worksheet filled out for the different stresses, take a picture of it and submit that as your first lab report for this unit.